这句吗？是，是哪个？对，到底有。
啊，一定要这一层，那你不喜欢？因为它这个是它的键盘呢。
为什么不喜欢用这些？
滑鼠键盘能用。它这个滑鼠的键盘是电，你把电池给我。
不然等一下，等我讲。
有是电池的。
我先让大家先介绍，然后等到这边 ready 就可以了。
我还是这么想。
换个键。没有换新的，接收器上。
Okay, I think I will start to introduce O3T and the jury. So we still have some technical problems. So the official fight will wait until the people free. So welcome to the 16 UIPT. This is the first time the team actor to introduce the team member. Let's start from the
I'm the captain of PS1, and I'm Xian, and she's a rep, and Wang Yan, Minyu, Thank you.
Thank you. Then opponent.
Hello, we are all physics, and I'm Chen Mingyi. He is Chen Boyu. He is Wu Pingwei. Thank you.
Okay, thank you.
Okay, my name is Andrew. I'm the leader of the Lab Rangers team, and this is Daniel. This is Bernie. This is Howard, and this is Hans. Thank you.
Okay, thank you. Then I will introduce the jury. Let me start from the
Hello, 大家好，我是张明。
所以说开始了。
应该是课教本老师。
60要做。60要怎样？说数学题。
Okay, my name is Qian Hao from Zhongzheng University. So going to wait. It's okay? No.
那你是看你能不能投上去。没有，我不知道。你买电脑一罐。电脑一罐。
它有显示的还是写知道。
应该如果这个不行，就是关键到这个上下讲，我这个是真的。如果我测试一下，
你的可以。
换成问一下，然后问一下。
这样是。
会倒掉。来把手试试。
Okay, let's start the first fight of this one. Okay, then I would like to ask the opponent pick a problem to challenge the reporter. You have for 1 minute.
你要去挑战，你要挑战哪一题？所以我这题。你要哪一题？
我讲完
Oh, shoot.
shoot rockets.
Some.
We are going to try the shooting rubber band.
Which one? Problem number.
Number 4.
Okay. Problem number 4. Shooting rubber band. Only there is 1 minute to get the challenge. Okay, problem is still reject. Okay, opponent, you have another minute to pick up another problem. Please.
We're going to try another levitation, number 8.
Okay, problem number 8. Another magnetic definition.
Reject.
Okay, option has been reject. So opponent, you have another minute to pick up another one.
你做，你有做，来做。在这个，这是几题？这是几题？他不是做，做的是还是发生的？we're trying to the number 7, giant sounding plate.
Okay, problem number 7. Giant sounding plate. Okay, option is being rejected. So opponent, you have another minute to pick up another one.
We're trying the charge manner.
Charge. Which one? Okay. 13. Okay. Option number 13. Charge meter. Okay, time's up. Accept. Okay, problem being accept. Okay, so the opponent has 5 minutes to prepare your presentation. So I also want ask each team, please write down the presenter name on the blackboard. 记录那个 reject。The reporter, opponent, and the judge's research. Chinese okay. Who will take the floor to write down the name on the rebel?
这个里面的人如果叫他们你先把它就是提好，所有评论提好。
Okay, reporter, please.
Good afternoon, honorable judges, my partners and competitors. Today I'm going to present problem number 13, charge meter, and I'm Ethan Zhang from Team Lingdao PF1. And this is the outline of our presentation. So the problem statement is that a lightweight ball is suspended from a thread in the area between two charge plates. If the ball is also charged, it will be deflected to one side at a certain angle. What is the accuracy of such a device for measuring the amount of charge on the ball? And optimize your device to measure the smallest possible charge on the ball. And then is the experimental setup. So we have a ball and strings, iron plates, and support column, transformer, power supply, conductive silver, paint. And this is the picture of our first experiment, which is static equilibrium. And this is the demonstration video of Franklin Bill. So you can see the ball between two iron plates is moving. And this is the phenomenon explanation. So first is the static equilibrium. So the ratio of the electric force to the gravity force is equal to the ratio of x to L. Because the angle is really small, so it's similar to the L, which is the length of the thread. And by rearranging this formula, we can get the charge on the ball, which is this one. And then the next is the Franklin Bill. First, we define the beta. The value beta is V2, which is the velocity after hitting the plate, divided by the V1, which is the velocity before hitting the plate. And then because it's the conservation of energy and it's a constant acceleration motion, so we can get this formula, which is also the charge on the ball. And this is the prerequisites, which we control the humidity in 40% and temperature in 25 Celsius. So in our first experiment, which is static equilibrium, we changed the weight of the ball from 100 gram, 200, and 300. And the 100 gram ball, the radius is 0.2 and 0.3 centimeter. And the 200 gram ball is 0.4 and 0.5 centimeter. And 300 gram ball is 0.6 centimeter. And we control the distance between two plates, which is 4 centimeter. And then the next one, we change the charge of the two plates, which is 1040, 2018, and 3120 volts. So this is our result. We can see that the blue one, this is 100 gram ball with 0.3 centimeter radius. So as the voltage is larger, the distance that the ball is lifted out is larger. And the lighter ball will be lifted out much longer distance. And because of the charge on the ball is calculated by this formula, so we can know that the charge on the ball is right here, the average of the charge of the ball. So if we see these two one, we can know that when it's same with 100 gram, when the ball radius is larger, the charge of the ball is larger. And the next one is Bradley Bell, which we change the same thing as the experiment format, the weight of the ball and the charge of the two plates. And as we stated before, the value of beta is V2 divided by V1, and the value of beta is like this on the right side. And this is the experiment result. So we can see that this is the 100 gram and 0.3 centimeter. And when the voltage is larger, the frequency will be larger. And this one is the same. Voltage is larger and the frequency is larger. And this one is also the same. So because of the formula we used in the theory before, we can know that the average of the charge of the ball is right here. So when the and here's the discussion. So the charge of the ball is the formula right here, and the surface charge density in the experiment static equilibrium is similar to the surface charge density in Franklin Bell. So we can know that the surface charge density is smaller for Franklin Bell, but it's similar. So the data we collected in our experiment is accurate. And in Franklin Bell experiments, the frequency increases as the voltage increases. And the ball with 100 gram mass, 0.3 centimeter radius can be measured by smaller voltages. And this is the end of our presentation. Thank you.
Holden, please take the floor. You can ask some short questions. Holden, yes, please take the floor.
Could you turn to the theory? Have you tried to change the distance of each sheet?
We say that we control the distance is 4 centimeter, right? And because the 4 centimeter distance is the angle is more obvious. It's the most obvious one. We change, yeah. But the 4 centimeter is most obvious, so we choose the 4 centimeter one.
Okay, this is my whole part.
Okay, I have 3 minutes to prepare your presentation. Okay, opponent, please take a seat.
We are going to talk about the charge method. And for the most important thing is how to optimize the device and to measure. Okay, and their phenomenon is to make the plate distance is 4 centimeters. But we have no idea on how the ball may touch the plate or not. So we have better to check whether the ball touches the wall or not. Okay, this is our opponent.
So can start the discussion. Reporter, please take a floor. Just 40 minutes total for the discussion. We can take some question.
Have your ball touched the plate in your
Yes.
experiment?
Yes.
How can you measure the exactly? How can you measure the exactly amount on the ball after it touched the plate?
Sorry, what's the amount on the ball? I don't know. Sorry.
How can you measure the exact charge on the ball after it touched the plate?
By this formula. So so we have the value of beta, which is V2 divided by V1, and we use tracker to know the velocity, and we also have the mass and the distance between the plates. And the frequency, which is also used by, also calculated by the tracker, so we can know the charge on the ball. Yeah.
But the ball will rotate in your experiment. How can you check the exact charge on exactly velocity on the ball.
The velocity before hitting the plate and the velocity after hitting the plate. So we just have to track the ball.
But the ball will rotate.
That doesn't matter. You just have to track the ball. And in our experiment, the ball won't rotate.
Please return to the experiment setup.
What's your next question?
Could your ball hit the same velocity after touch the plate?
We have V1 and V2, so the velocity will be the same.
In my question, I mean, after hitting the plate, all of the velocity after hitting the plate would be the same. Would all of the V2
Yes.
is
yes.
hitting the plate, right? And after that, all of the velocity will be the same.
You can see here and here and here is the same. It's the same train, the slope.
Okay, I'm done.
So, okay, you can summarize your discussion. Do you have anything you want to say? You have 1 minute to summarize the discussion.
They could measure the smallest charge on the ball. Yeah.
Okay, time's up. Question from the viewer. Please take the floor.
Okay, so can the reporter turn to page 30? Well, is this a curve or line? Because it looks more like a curve than a line. And have you got any data about the slope, or can you prove it with the r squared to tell me that it's a line? So does the opponent think this is a line or a curve? Or okay, so the next question. The opponent says that the ball might rotate. Is that correct?
Yes.
Yes. So the jury, can I use the blackboard? If the ball rotates, do you think it will rotate like this?
No, I mean the ball will rotate on itself.
Like you mean this?
Yes.
The ball rotates on its axis like
Yeah.
that? Okay. So do you think that in this experiment the ball will also rotate like this?
No.
And what about the reporter? What do you think about this? Will the ball rotate on its axis?
No.
Or focus? And how do you make sure that this doesn't happen? Have you tried to shoot with a camera vertically with your experiment and to check? And do you have any data on that?
We haven't put on this, but we use a like point on the ball, and then we see that the ball will rotate on itself.
We will rotate on the will rotate like this. No. So why does the opponent think that it will rotate? Can you explain?
Because the ball is not, it's not just put on the floor.
Oh, well, that's a valid point. I think that this might rotate, and you should have considered putting in any data about this. Okay. To the reporter, how do you get the optimal distance in this experiment? Because you didn't change the distance. Like the opponent just talked about how to change the distance, and why didn't you do it in your experiment? Explain.
We changed the distance before the experiment, and we think that the 4 centimeter is the greatest one, so we use this 4 centimeter.
Okay, you will have 2 minutes to prepare your presentation.
起码没有对我说，对我说的这是坏球。现在讲。我找不着。
Please start.
Okay, I'm the reviewer of the Lagrange team, and this is problem number 14, charge meter. For the reporter, I think she has great understanding of the problem statement and the clear experimental setup, but she didn't consider making an optimal distance, and I don't know why. Well, when their experiment is changing the mass, they didn't consider the radius change, or when they are changing the radius and they didn't consider the mass in it, and I don't quite know how can you do an experiment like that. And she lacks explanation of correlation between the radius and charge, like I have said about the radius change. And the opponent, he asks some critical questions, like how the ball might rotate, and pointed out the main focus is to find the optimal way to charge, to do a meter with the charge. But it also has some cons that the opponent could dig deeper on this experiment, and he didn't prepare enough questions. And the report presented is quite blank and has an invalid summary. The first question the opponent had asked is about the sheet distance. Well, the reporter says that the distance is controlled at 4 centimeters in order to make the angle obvious. Well, the reviewer, I think that the reporter should do more experiments to try to explain how their theory correlates with their data. Also, another question the opponent asked is have the ball touched the plate and how to measure the charge. And the reporter says that they use tracker to measure the velocity and using mass and distance with their formula, and they can calculate the charge of the ball. And another question the opponent had asked is about the ball rotating and whether it would affect the experimental results. And the reporter says that it doesn't matter and it won't rotate. Well, I think that the rotation should be considered clearly, since that the rotation like this should be like a simple harmonic motion, and you can see from the graph that it is not a line, and it should be something like a curvature. And the forces should be considered clearly when it is rotating. And the reporter should also have some manners when asked about these kinds of questions. And the opponent also asks whether the collision is elastic or not. And the reporter uses data to prove that the velocity stays the same. Well, however, I think she can also calculate the coefficient of restitution during the collision of the plate, and you can make a graph to make it more precise. And another question the opponent asked is about how to get the optimal distance. This question I asked, and the reporter didn't answer, and the opponent, well, didn't answer as well. Okay, thank you. That will be my report.
Okay, thank you. Concluding remarks from the reporter. Please start.
And this is my concluding remarks. So first, the measurement can be done by 2 experiments, which is static equilibrium and fracking belt. And second, we do not observe rotation in our experiment. And the third, we control the velocity to be the same for different voltages. And the graph of the position and time are straight lines because the change in the velocity is relatively small to observe. And next, we did consider the radius of the ball in the equation of the charge on the ball. And we can put more experiment data to be more specific in explaining other factors that we think we do not affect a lot yet. And this is the end of our concluding remarks. Thank you.
Okay, thank you. A question from the jury. On this reading, please extend. A question from the jury?
So I have a question for three of you. How to get the optimized distance, as the final reviewer asked, how to get the optimized, as the question asked, how to optimize your device to measure the smallest possible charge on the ball. You do not answer this question. I would like to ask three of you. So, please.
To get the smallest or 70.
To measure the smallest possible charge on the ball. The last sentence in this topic.
之前跟我在做实验，完全跟我们做实验，跟我们做实验，我今天怎么
How about opponents? Do you answer?
May I have may I give me some seconds to prepare my answer?
How about here?
Okay, we can put the ball and use a mirror on the ball, and we use light to move the mirror and make it reflect. That way we can measure some very, very small angles to make the measurement of the charges much smaller than what we do with tracker or other tools.
How about, would you like to answer this question?
Answer something?
So when I do this experiment, I use to separate the force to count the charge on the ball, and also it may have the moment of inertia on it. So we have to count all of the elements to get the smallest charge on the ball.
We use the static equilibrium and friendly field and to measure the potential differences and to get the smallest one.
Okay, you use equation.
Huh?
Equation.
Yeah.
And yeah, the jury say, this is not only a question about measuring charge, it is a question about the uncertainty or the accuracy of measuring charge. So what is the typical uncertainty in your experiment? I believe that all of you have done the experiment.
The question?
What is the typical uncertainty in your measurement?
You mean the cause of uncertainty or
Charge uncertainty.
you mean the uncertainty of the charge measurement?
Yes, your measurement.
You want me to explain the cause or?
The typical value. And does it make sense?
Okay,
You
can
can
you rephrase it?
comment.
Can you rephrase it?
Comment that your measurement is reliable based on your uncertainty.
Yes, it's precise or uncertain.
Yes. So please show me the typical measuring uncertainty or typical uncertainty of your measurement. If you have from the paper.
For every data we collected, we have calculated the uncertainty and we choose the smallest one.
So do the uncertainty means that the minimum charge you can measure or not?
No.
So
No.
why?
It's just accuracy.
Accuracy is not the most important thing here, right?
Yeah.
We want to make the best, to optimize, to get the best accuracy.
Yes.
So the uncertainty, do the uncertainty equal to the accuracy here?
Yes.
Okay.
Well, to add on, I think that what they're saying is the precision of the charge and not the uncertainty of the experiment, because you need to correlate your data and your what it is actually what the real number is, and that's about precision and not uncertainty. So when we're talking about accuracy, we're just talking about how the meter matches up with the real life numbers to get an accurate prediction.
Anything you want to say?
We just try to change the distance on it and also how high the ball has to try to get the best device on this experiment.
Okay. I think that the time's up, so go to the going section.
我要数光，我再帮你留下，我再帮你加1嘛，我也要数光。
Yes, go to the scoring station that starts from the reporter. Joy with the ratio. 5, 4, 5, 6, 6. Thank you. Then the opponent. Four, 3, 5, 5, 5. Then reviewer. Yes, please. 7, 6, 7, 7, 8. Okay. Thank you. So, Joey, anyone want to make some comment?
Well,
Yes, please.
I would like to suggest the opponent may try to use your time more efficient, can ask more questions and discuss more with the reporter. That would be better for you and your team to understand this topic more. So I encourage you for your next section, please try to use your time more efficiently, to use all of the time you can have.
All right, thank you.
So, let's take a 10 minutes break. Before moving, please.